Hello, my name is Scott Mathewson, and I'm with SoftChoice in the software-defined data center practice. I really appreciate you taking the time today to talk to us a little bit more about software-defined data centers and really more importantly, software-defined networking. And that's been a really huge focus for security with most of our customers today, and I want to spend a little bit of time and talk a little bit more detail around software-defined networking. I'm with the software-defined data center practice at SoftChoice. We have a lot of great relationships today with software and hardware vendors. We have great relationships with Cisco and Microsoft, both in Azure and with hosted Office 360. We have great relationships with VMware. We have great relationships in the Cisco space across their entire platform, and then also around HP, IBM. And then we're looking also at some of the converged and hyper-converged infrastructures with Nutanix and others. So it's definitely a very exciting time to be in the marketplace right now. And you've seen many customers using hypervisors today, whether it's vSphere, Hyper-V, Red Hat. Most customers are using some sort of operations management as well to sort of figure out what's happening in the environment today and keeping tabs on the performance and then also automation type software and workflow software that we see today in Microsoft, VMware, and Cisco even doing that with some of the ECS manager and being able to deploy hard metal infrastructure and then also be able to build virtual infrastructure on top of that. So there's a lot of things going on in software defined today that really allow us to take and abstract the storage, the compute, networking, and we see that in regardless of what vendor you're using today. You know, typically what we've seen is a rack or blade mounted servers taking advantage of the compute capacity. And then typically we see that switched out and then shared storage arrays. And typically what that allows is then virtual machines to run, essentially be able to move them around in the hardware, various locations based on the performance profiles. So regardless of what hypervisor you're using, that's typically what we've seen happening, right? And in all of these architectures, the storage, compute, networking is virtualized, it's pooled, it's delivered on demand. We usually have some kind of operations and control of that data center, and we try to automate as much of that as possible through policies and through templates. And then you have the line of businesses come and consume this infrastructure through some type of a deployment infrastructure, either an automated or some sort of self-service workflow or a manual workflow process in order to be able to build out the server and storage profiles that are needed. SDDC typically will reduce quite a bit annually in provisioning and management operational costs just because we're using hyper-converged infrastructure and we're using single interfaces in many cases to get to that. And then obviously the calendar days that's required to actually provision a production workload for new applications is usually reduced from many weeks down to minutes or days. And then obviously as we can get more and more performance and consolidation out of this environment, then it provides us even more ability to save from a cost perspective because we're getting much more reduction in the amount of hardware that it's going to take to run these workloads. And what we're seeing is in every generation of the Intel processors, we're getting much more performance. We can tell in every release of storage, right, we're getting flash and faster storage arrays. It's getting smaller footprint. We're seeing more and more hyper-converged so that all the elements that are needed are in this array, and we can be able to use policy to move them around. So a lot of really big things happening. What's typically been the big downfall has been the automation in the network space, right? And typically what we've seen is we have a lot of switching capacity, and anytime we want new networks and new switches, typically we have to go to some sort of network administrator, right, that's administering the switches, and then we might have load balancers built in here as well, so that we can distribute the workloads of how they're going to go, right? And then typically we'll have some sort of firewall protection that's built in and we'll be able to firewall all the reads and writes that come in and out. And then typically, we'll have DMZ zones that are also set up, and in the DMZ, is where we typically will find VPN services and other ways to sort of get into the environment here. So all this requires a lot of switching infrastructure, requires a lot of tables for firewall rules, load balance table. We have to maintain all the VLANs, right? And we have to build VLANs, and we have to segment all of the services out into VLANs so that we can then expose them into a virtualized world and then create virtual networking. And if you're in the VMware world, you're usually using the virtual distributed switch. And if you're in the Hyper-V world, you're using the networking stack through the data center version of Microsoft Hypervisor. So one way or another, you're putting some limited networking information in here, and we're really relying on sort of what that underlying infrastructure is, how much this has been maintained, how much has been switched, how much has been over provisioned, what type of protocols are being used on here, where we've got storage traffic that's taken iSCSI or fiber channel formats. And so we have a lot of switching infrastructure and a lot of management from a firewall and from a security perspective. And really what that's done is kind of a little bit inhibited the deployment of some virtualization, because we still have to rely on this, right? We can't just say we're going to, automate an entire workload process that's going to provide us a DevOps environment, let's say. All right, let's say we want to replicate the entire production environment and we want to create DevOps with our production environment. We just want to replicate it, keep it secured off from the rest of our environment, and we want to be able to run the exact same IP range that we're running to here. So something like that, right? We just can't really do that easily today without physically separating out these tasks, right? And physically turning on a port here to only enable that and limit the access that's going to go out here. And we're going to have to put that in the firewall rule table and limit the access of where those VMs go, right? A lot of work that's being done here is somewhat limited because of the infrastructure that we've got to go out on. So a lot of manual routing tables and a lot of infrastructure that's got to be maintained. And so when we talk about SDN, it's not really a specific technology. It's really more of a concept or a framework. It's not really a protocol. It just aims to control the various network devices. And then the biggest thing is enabling automation capabilities. It's designed to push out and roll back changes and provide network presence, and essentially, that status can be monitored throughout the networks and providing better information to network administrators, and possibly also direct changes to network topology and traffic flow and so forth. So we've seen a large shift in transformation in networking as more and more enterprises want to virtualize more and more of the environment. We're getting huge advances in speed, agility, and security, and we want much more flexibility in where we run our virtual machines. Because in the virtual world today, we know we can program, we can copy, we can delete, we can archive, and so we can take a whole environment, we can archive it, we can copy it, we can back it up, right? And that's great. But unless we have some really complex system of recovery, something like SRM, or in the VM world, or we have something in the storage world that does storage replication between the arrays that is virtual aware. Unless we have something like that, it's really challenging to make sure that all the networking space is available for us in the format that we want it in. Also, we want to be able to take basically the same security automation microsegmentation that we've been doing in the compute space, and we want to be able to take that same topology and apply it to the networking space. So we want to be able to do really granular security around applications or virtual machines as a security boundary, instead of the infrastructure and physical input and output into the physical world as the boundary, right? And if we can do that, that gives us much more flexibility around where that application can be run, how it's run, and what type of things are available to it. So usually what we've seen kind of in the past is, using the x86, using server hypervisor, being able to take any general purpose hardware and running the virtualization layer on top of it, right? And then being able to do all types of policy and be able to segment and group our VMs, right? We want to be able to do that same type of approach to software-defined networking. So we want to basically decouple the network services that are being provided over here. So things like layer 2, layer 3, right? Layers 4 through 7. We want to be able to take all these things that we would apply in the networking aspect of an application around load balancing, firewalling, and other network services that we might want to go to, and we want to be able to put those on any kind of general purpose networking hardware, right? So whether we're doing it from software-defined networking from the hypervisor, or whether we're building it into a virtual switch that we're building out into a physical network, the concept is really the same. We want to be able to scale resources when we need them, as we need them. And one of the biggest problems that we're seeing today is that if there are breaches in the network today, people are coming in typically through the firewall. Once they get past this spot and they're into your virtual machines, right? They're in the SQL database, right? Then basically they can go throughout the entire environment, right? There's nothing from a networking perspective that's really stopping that. They may be VLAN'd out and segmented that way, but once something is inside the network, there's really nothing to stop that, right? And so it's a little bit of a single point of failure, although there are more things that are being done in the data center beyond just perimeter security, but typically that's the main thing that we're relying on when it comes to threats. And then once, one of these VMs is infected, it essentially can spread to the rest of the environment. And the attack surface is very large because there's really nothing stopping any of those infections from going out throughout the environment. And then we also have a lot of cases where we've got sort of viruses that may get in and sit for long periods of time, so we may not even know we've been infected. And because that becomes a really big problem. We're seeing more and more security breaches, and typically what happens is people will be getting in through the firewall, they're getting in here, and they start hacking away into various databases that are within the virtual infrastructure. And so it makes it very challenging to make a really good perimeter defense security argument there when we've got so much going on within the actual application itself. So what we really want to be able to do is sort of make a model that sort of assumes that the trust is the least privilege. So we're just going to assume sort of that every application that we build, so let's say we automate and we build out a 3-tier application, has a database, SQL database, has a web front end, and then we're running it on operating system, Windows 2013. So we know that when we deploy this group of machines, that we're going to also apply policy around storage, right? What type of storage does it need? What is the performance characteristics? We know we're going to put a compute. All right, we're going to say DRS is involved, and we know it's going to have this type of profile for performance. So we have a storage, we have a compute, and now we can build a network profile. And we can say, this thing needs its own firewall. Let's build in 2 load balancers, and let's do this on the fly. And so all of those operations from load balancer, firewall, all those services are now going to be done in a policy, and it's going to be done when the VM is created, right? So now all of that policy becomes wrapped into our application, and the application has a security boundary. It has all the storage and compute needs, and so as this application needs to move around, so let's say we want to move DRS, wants to move it from here over to here, and it's on a separate VLAN or a separate network segment altogether, right? The ability to do that now, once it's encapsulated, is I can move it anywhere I want to. And as a matter of fact, if I'm making calls within here, I can put policies in to say everything you need is within these 3 VMs. You don't even need to go outside of that VM at all. So as soon as I get traffic requests coming out of here and going into something else, I can be alerted right away, and I know that there's a problem, right? Because I can really segment that traffic. The other thing that it will help us with is if I'm going from a VM here over to a VM here, and all I need to do is go like that, right from here to here. In the traditional network world, I got to come out and switch all the way through to the core router, or at least get routing tables in here, and then come back through and move over here, right? If I've been able to do all the networking policies within the hypervisor, right, I can just go right where I need to go back and forth and eliminate all that latency there. So that's the other part about building that sort of knowledge and policy into the application, is I can severely limit the amount of traffic that's happening, and I can severely limit the firewall policies and the amount of security that I'm going to wrap around that particular application. You know, basically I could put a firewall for every workload, which physically would be impossible. In the Cisco world, they're building essentially that same software-defined networking into modules that are on the NX9000, right? So you can take these modules, you can key distribute those at top of rack or end of row, and I can use the ACI policy in Cisco and start virtually creating some of this environment like I was talking about here, and it's integrated into VMware as well. So there's a couple different ways to go from software defined, depending on how you want to do that, right? You're going to get in the 9000 the additional backplane to kind of carry out the throughput for those increased operations. In the VM world, you're going to have vSphere be able to run that natively on the host with the NSX components in it, and essentially will allow you to scale at the hypervisor backplane using the server arrays that you've got instead of using the switch array. So the same kind of concept is we're going to be getting that switching infrastructure in the backplane of the hardware. This is what's going to allow us to scale, and the amount of workloads that we can scale to is going to be extremely large, right? And really, what you look at from a software-defined networking aspect is really going to depend on what type of investments you've had today, who you're investing in today, and which direction you want to look at there. In the VMware NSX stack, you're going to complete all the network construct inside the virtualization layer. So the virtual network can include all the L2 switching, the layer 3 routing, load balancing firewalls, VPNs, ACLs, quality of service. Just like you would expect in a switch vendor, you're going to get all of that out of the hypervisor now, because we've been able to pool all of that capacity just like we could in compute and network. We can actually make a transparent pool there for networking and build those policies with network policy templates. So, you know, if you're a huge VMware shop and you're looking at software-defined networking, NSX is definitely the way to go. If you're not a big VMware shop and you're maybe a Microsoft shop for hypervisor there, you don't have software-defined networking per se built in, but then you can use, you know, a Cisco approach. Or if you're a big Cisco shop and you want to use policy-based automation solution, you'll be looking at the Nexus 9000s along with the ACI technology built in. And obviously, there's a greater scalability there as you build out that 9000 infrastructure and those ACI switches based on the amount of throughput and traffic you're going to have in a virtualized world on the Cisco switches. So you get the integration of the physical and virtual environment, and you do get to run that through your Cisco policy model. So slightly different implementations depending on which way you want to go. And really, from our perspective at SoftChoice, we really want to be able to be a trusted advisor for our customers and help them make kind of the right choice on which way they can go. And so our expertise around the VMware stack, around our Cisco stack, and we've been cross-training our CCIEs to be NSX certified folks. And so, there's a lot of different pros and cons around each particular implementation of whether it's NSX or it's ACI from Cisco. But basically, the drivers are the same, right? We need more security, we need more automation. We have a complex network that's hard to manage with the traditional tools. We have the visibility issue of virtualizing and moving workloads around, and networking components are not often visible in there, and we can't really policy as well as we need to. So we really truly need to automate as much as possible. We need to reduce the operational costs that are linked to network maintenance as well. And we want to make sure that we get as much flexibility as we possibly can in the software-defined world. And for us at SoftChoice, right, we're going to be essentially helping you make those decisions and those building blocks for getting you ready for software-defined. There's really little reason to maintain or leverage, ACI and NSX simultaneously. A lot of duplication there. And Cisco is a great platform for fast, reliable fabric for NSX. So you can do spine and leaf on the 9K, and you could virtualize in NSX. And same thing with Cisco. If you want to virtualize with ACI, you can still use your VM environment too. So we want to help make the best choice for you. And I appreciate you taking the time today to learn a little bit more about software-defined networking. I hope you have a great day.